It's that time again. Time to do some geometry. So let's see what we got in a warm-up. At a location 50 feet from the base of a fir tree, the angle to the top of the tree is 43 degrees. Find the height of the tree. Well, let's finish this off. We'll call the height of the tree x. So I'm at the 43-degree angle. I want the side opposite. I have the side adjacent, and there's only one trig functions for opposites and adjacents. That's tangent. The tan of the 43-degree angle equals opposite x over adjacent 50. To get x by itself, multiply both sides by 50. So x is 50 times the tangent of 43 degrees. If you punch that in your calculator correctly, the height of the tree is about 46.6, and since it's an applied problem, there's usually units involved, so that is in feet. All right, just a quick review here about SOHCAHTOA. Easy little phrase to remember. I like to write it like this. S is O over H. Sine is opposite over hypotenuse. Cos is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. And a nice way to remember all of those is some old hippie came a hoppin' through our apartment. Some old hippie came a hoppin' through our apartment. Okay, a little fill in the blank here. To solve a right triangle means to find each side length and also each interior angle measure. A triangle has 3 sides and 3 angles. To solve a triangle, we have to know all of them. So here in example 1, we've got a picture to go with it. I'm going to redraw the triangle below. So we've got a 65-foot cliff. There's an eagle on top of it, spots a fish, and dives toward the eagle. When the eagle dives off the cliff, it creates a 36-degree angle. And they're calling this vertex B, this side C, and A is up top. So the directions say solve the triangle and round each angle to the nearest tenth. So angle C is our right angle, 90 degrees. Angle A is 36. Angle B is going to be 90 minus 36. And that's going to be 54 degrees. So angle B is 54. Let's write that in on the picture. And now let's start solving for some of the sides. Let me move this up. So just for convenience, I'm going to call this side BC is X, and the hypotenuse AB is Y. So let's see. I'm here at the 36-degree angle. If I want to solve for X, X is opposite, and then I have the adjacent side. So we could use tangent, because tangent is opposite over adjacent. The tangent of 36 degrees is X over 65. And then to get X by itself, we're going to multiply both sides by 65. So X is going to be 65 times the tangent of 36. And again, I called that side X, but it's really side BC. BC is about 47.2. Don't forget the units. Feet. All right. So we've got X, or BC. This side is 47.2. Now we could do Pythagorean theorem, but I like using my trig functions. So let's call for side Y. I'll go back to my 36-degree angle. I have adjacent, and I want hypotenuse. So that's going to be cos. The cos of 36 degrees equals 65 over Y. So we can multiply both sides by Y and divide by cos 36. And our Y variable is 65 divided by the cos of 36 degrees. We punch that in the calculator. Again, that's side Y, or we could go back to calling it hypotenuse AB. AB is approximately 80.3. Again, don't forget the units, feet. Okay, I hope the eagle enjoyed his fish. So let's look at the picture here real quick. We got from this person, we have a line going straight out. If they look up at some object, that is called an angle of elevation. Think of an elevator takes you up. We look up at an angle of elevation to an object above us. But if we see something below, like the eagle saw the fish, that would be an angle of depression, angle down. So our fill in the blank here, the first one, the angle of elevation is the angle formed by a horizontal line and a line of sight to an object above. And an angle of depression is the angle formed by a horizontal line and a line of sight to a point below. So here, in example 2, we've got a boat on the surface of the water. It detects a whale that is exactly 42 feet away. So if we look at the pic, maybe the boat sensor is here, and the distance to the whale is 42. That looks like it's the hypotenuse of our right triangle. The angle of depression is 20 degrees. Now watch out here. Many times these angles of depression are outside of our triangle. So here's our horizontal line, the surface of the water. The angle of depression takes us down to that line that takes us to the whale. That's our 20-degree angle. So I'm going to make this a little bigger. So we need to find that angle in our triangle. Well, of course, this is a right angle. If we subtract 20 degrees from that right angle, what we have inside our triangle is 70 degrees. So we have our angle inside the triangle. We have 42 feet as our hypotenuse, and we're asked to find y, the depth of the whale, and x, the horizontal distance away from the between the boat and the whale. So let's say we're going to go after x first. If I'm at my 70-degree angle, x is opposite, hypotenuse is given. So what deals with opposites and hypotenuse? That's going to be the sine. The sine of 70 equals x over 42. And we're going to multiply both sides by 42. So our x distance is 42 times the sine of 70 degrees. And we punch that in our calculator. And that is about 39.5 feet. Now, if I draw it here on the picture, that makes sense. Remember, the hypotenuse is always the biggest side, so any of the legs we find should be less than 42. And that looks good, and I almost forgot my units, feet. Okay, now let's find y, the depth of the whale. Again, I'm back at my 70-degree angle. I want the adjacent side, and I have the hypotenuse. So that's going to be cos. The cos of 70 equals adjacent y over hypotenuse 42, and we multiply both sides by 42. So our y value is 42 times the cos of 70 degrees. And we punch it in our calculator, and we get about 14.4 feet deep. Okay, example 3. We've got a picture here, a triangle graphed in a Cartesian plane. Find the side lengths to the nearest tenth, measure each angle to the nearest degree. So I'm going to just list my sides here. Zx, that's easy, we just count the boxes. Zx is 5. Xy, here's 4 boxes and then 5 more. So xy is equal to 9. I'm going to write it in here, 9. And now to find zy, the hypotenuse, let's do a little Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. I square the 5, I square the 9, I add them up and get 106 is equal to c squared. So c is the root of 106, but it says find side lengths to the nearest tenth. So let's grab our calculator and root that 106, and we're going to get our hypotenuse zy is about 10.3. And I'm going to write that on my picture. Now, they're asking us to find the angles. Well, angle X is easy. That's our right angle. That's 90 degrees. Now, let's find our two acute angles, Y and Z. We have all three sides, so we can use any of the trig functions. So I'm going to set this up all three ways. If I'm at angle Y and I use my opposite and adjacent side, that would be tangent. So I could do the tan of Y is equal to 5/9, and then I could divide and do the tan inverse. If you don't want to do that, we could have done the sine of angle Y. Sine is opposite over hypotenuse. And if you felt like it, you could have used cos. The cos of angle Y is equal to adjacent over hypotenuse. I personally would do the tangent because the 5 and the 9 have not been rounded off. We did round off this 10.3 for our hypotenuse. So if we do that, there'll be a little bit of rounding error in there, but I'm sure it would be all good. So if you do any of these, you're going to find angle Y is about 29 degrees. About 29 degrees. Now, if we're confident in that answer, we could subtract and you find angle Z that way, but I like using my trig functions. So I'm going to set up for angle Z. We could do the tan of Z is 9/5. Notice it's just a reciprocal of this. We could also do the sine of Z is 9/10.3. We could do the cos of Z is 5/10.3. Again, any of those should give you the good answer. Let's just stick with tangent. So we want to get Z alone. We're going to tan inverse. So angle Z is the tan inverse of 9/5. So we divide that. We do tan inverse. Angle Z is approximately 61 degrees. So there's all three sides, all three angles. We have solved the triangle. Okay, we just got one more example to go, and this one they give us no picture, nothing. We're going to have to draw it ourselves. I'm going to start with this. AB and BC are perpendicular. So I'm going to draw a couple sides coming together at a right angle. I guess I'll call this one AB, and I will call this one BC. So they're perpendicular, and now I see AC is my hypotenuse. I know that AC also is 5.8, and I know angle C up here is 35 degrees. So once again, the directions are solve the triangle. Angle A is just going to be 90 minus 35. So angle A is 55 degrees. Okay, I'm going to go back to the angle they gave us, 35. Let's say I want side AB, that's opposite, and I have hypotenuse. I could set up the sine of 35 is equal to AB divided by 5.8. So multiply both sides by 5.8, and we should get side AB is approximately 3.3. 3.3 inches. And now let's get side BC. BC to 35 is adjacent, and we still have the hypotenuse. So adjacent and hypotenuse would be cos. We could do the cos of 35 degrees equals BC over 5.8. Multiply both sides by 5.8, and we get side BC is about 4.8. So there we have solved the triangle. All sides, all angles have been accounted for. Now, before I tell you to pause the video and try the practice problem, let me give you a quick hint here. Where is it? In number 4, when you're counting the boxes, notice each box is 2. So be careful. I had a couple people make a mistake in class on that one. And here when we do the angle of depression, you know, that angle of depression might not be inside your triangle. You might need to use it to find the angle inside your triangle. So again, good time. Pause the video, try the problems, fire it back up, see if you got them right. Okay, so in the first one, we got a 12-foot ladder leaning against a tree. Angle of elevation up is 75. Round the values to the nearest tenth. We want to know how far up the tree does the ladder go. Let me get this, move this over. Oh, I guess those are attached, dang it. So how high up the ladder does it go from the tree? That would be our opposite side. And we have the hypotenuse. The ladder itself is 12 feet. So we could set up the sine of 75 equals opposite, let's just call it x, over hypotenuse 12. Sine of 75, multiply that by 12. The ladder is reaching about 11.6 feet up the tree. Part B, the distance between the tree and the base of the ladder. That'll be the side down here. Let's call it y. From 75 degrees, that would be the adjacent side. So the cos of 75 degrees is y over 12. Take the 75 cos and multiply by 12. That distance y is about 3.1 feet. Okay, practice problem 2. A tower casts a 24-meter shadow. Here's my tower. I'm going to draw in a shadow. I'll use black ink. And we know the length of that is 24 meters. The sun is situated where an angle of depression is 67 from an imaginary horizontal line through the top of the tower. So here's my imaginary horizontal line, and here comes the sun to cast that shadow. So as that comes down, our angle of depression here is 67 degrees. And of course that means we'll use that to find our angle inside the triangle. 90 minus 67 leaves us 23. We're trying to find the height of the tower. I'm just going to call it x. So from the 23-degree angle, x is adjacent, and I have the opposite. So it looks like we can do tan. The tangent of the 23-degree angle is opposite 24 over adjacent x. To solve and get x alone, we would multiply by x and divide by tan 23. So these, in effect, just switch places. X is equal to 24 divided by the tan of 23 degrees. If everything goes right with the calculator button pushing, the height of the tower is about 56.5 meters. In this one, we are going to have to draw our own triangle. It says angle y is a right angle. So I'm going to draw my triangle this way. Angle y is the right angle. And I'm just going to call this side x, or this angle x, and this angle z. So x is 22 degrees. 22 degrees here. YZ is 5. And it wants us to completely solve the triangle. So let's get rid of the easy stuff first. Angle Z is just equal to 90 minus 22. That is 68 degrees. Boom. And now, let's just see. I'm at 22, the 22-degree angle. I have the opposite, and let's find the adjacent first. So that would be tangent. The tangent of 22 degrees is equal to opposite 5 over side adjacent, or xy. And again, to get xy by itself, we'll multiply by that and divide by tan 22. So xy is 5 divided by the tan of 22 degrees. And that should come out to be approximately 12.4. Okay, one more thing to solve the triangle. We need the hypotenuse ZX, and I'm still at my 22-degree angle. I have the opposite side. I now want the hypotenuse, so that's going to be sine. The sine of 22 equals 5 over xz. So we're going to get xz alone, and that's equal to 5 over the sine of 22 degrees. And the calculator tells me that it is about 13.3. And I guess I need units. These are in centimeters. Okay, triangle solved, every angle accounted for, and every side. All right, in number 4, I gave you that hint. It says solve the triangle, round to the nearest hundredth. And let's see here. Let's do the sides first. PQ, that's an easy one. We can count the boxes. 2, 4, 6, 8. So PQ is length 8. RQ is our vertical line. That's 2, 4, 6, 8 and a half. That'd be 9, length 9. RQ is 9. PR is going to be the hypotenuse. So I'm going to switch to red ink and do a quick Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So 8 squares to 64, 9 squares to 81. That adds up to 145 is equal to hypotenuse squared. So let's square root, and we have the hypotenuse. A root of 145, they do want rounded to the hundredth. That would be 12.04. 12.04. Now what I like to do here, because we had to find the hypotenuse and we did round that off, I'm going to use red ink and I'm going to go down here to angle P. We have the opposite side, 9. We have the adjacent side, 8. So we could do the tan of P is equal to 9 over 8. And then, of course, to get angle P alone, we're going to use tan inverse. So 9 divided by 8 equals tan inverse. Angle P is about 48.37 degrees. Now I'm going to switch to blue ink, and I'm going to come up here to angle R. And from angle R, 8 is opposite, 9 is adjacent. So we're going to use tangent again. The tan of R is 8 over 9. Look at these. So those are just reciprocals. We move to the other angle, our tangent value flipped over. So angle R is the tan inverse of 8/9. And our angle R from the calculator is about 41.63. If I wanted to, I could add these together to verify they do add up to 90, and they do. All right, one more. So we're going to draw a triangle. I'm going to do a triangle like this. Angle M is 90. Here's angle M. I'm going to put N up here and L down here. Angle L is 24 degrees. LM is 11. Boom, boom. They ask us to solve the triangle. So real easy is angle N. Angle N, 90 minus 24, is 66 degrees. And now we need to find some sides. So let's go to 24. Let's get NM first. That's opposite. We have adjacent. So that looks like a job for tangent. The tan of 24 equals NM over 11. Tan of 24, multiply both sides by 11. NM is about 4.9. Units are centimeters. All right. Let's see here. We want the hypotenuse, NL. So we're at 24. We have the adjacent side 11. We want hypotenuse. Adjacent and hypotenuse means cos. The cos of 24 degrees equals 11 over NL. Multiply by NL, divide by cos 24. So the side length of NL is 11 divided by cos 24 degrees. Punch it in the calculator. We get our hypotenuse NL. It rounds to about 12 centimeters. And that makes sense. The hypotenuse should be the longest side. It is longer than 11. It is longer than our 4.9. All right. All good things must come to an end, including this geometry video. I hope it was helpful.